Hello, this is week 5. My name's Eric and I'll be showing you the Python demo related to this week's activity and also be going a bit more in depth into the concepts related to Python build tools that Professor Horton might have briefly mentioned or covered. I'll just be diving deeper into them in this video. So the first kind of concept / topic that I want to go over is that of a package manager, and with regards to Python, that package manager will be called pip. Now, what exactly is a package manager in a bit more detail? Well, the term package manager has two parts, package and manager. And the first part, package, simply refers to a piece of code that you might use in your project that someone else, some other developer, some other organization has developed themselves, right? And what distinguishes a package from, say, a Git repo, right? A package should be easy to incorporate into your project, right? So if you can think about a Git repo, if you had to clone, say, the repositories, the Git repositories, the GitHub, if you had to clone, say, the GitHub repositories of all of the sort of pieces of code that you might want for your project, that could get hairy very quickly, because modern programs, especially these days, depend on hundreds, sometimes thousands of these packages, of these pieces of code, right? And they range from libraries that deal with high order math functions to simple text parsing libraries to configuration libraries. They're everywhere. And so having to manually go through to the GitHub pages, clone them, copy the code, and then don't even get started on the work it would take to update all these packages to the new versions, right? And so this is why people created these tools called package managers, right? These are programs that you run intermittently throughout the development process of your project in order to update and install any pieces of code, any packages that you might want. So pip is an example of a package manager for Python. And right here, I have my terminal and I'm inside the directory that contains the demo. Now, to show you pip really quick, I'll just run it right now. The command for Mac and Linux is going to be pip3, whereas the command for Windows is just going to be pip. For Windows, if you downloaded and installed Python from the website python.org, pip should be installed automatically. For macOS and Linux, it's going to be a little bit different. So if you're on Linux, you probably already know how to install pip if you don't already have it. For Mac OS, I believe there are several ways for you to install pip. They're all going to be written up, hopefully on the website, or perhaps it's going to be in a Google document. Either way, it's going to be there. If you don't have pip, it's either if you don't have pip already installed, most likely you'll just be running a Python program called get-pip, and this should handle everything for you on Mac. But after you've installed pip, you can simply run it as pip3. The 3 is referring to the version of Python 3. Now, the most common thing that you're going to do with pip is install a package, right? And the way you install a package is simply pip3 space install. Another common thing you're going to want to do is uninstall a package, and that's simply as follows. If you ever want to know how to do something in pip, all you got to do is either pip3-h or just as I've been doing like the past 3 times, just call pip3. Just type in pip3 and it'll show you, okay, what you can do. We can install, download, uninstall, freeze. It's going to come in handy later on. List, we can list all our installed packages right now. Search, we can search PyPy. That is the name of the sort of network of packages, of Python packages. And yep, there's help. And that seems to be everything that's generally used often. Now, just for fun, let me see what packages I have installed in my pip. Let's see. NumPy, PyLint, okay, and a lot of other stuff that I don't really recognize, to be honest. So that's pip, super simple, right? You have install, uninstall, list, freeze, go over later on. And that should be about it for all the commands to get you started. Now let's dive into virtual environments. So virtual environments sound kind of crazy, sound kind of complicated at first. In reality, all they are is simply the act of isolating your current project and its dependencies from the rest of your machine. So I mentioned how these days projects can grow to hundreds of thousands of dependencies, of packages, of other people's code that you depend on. And things get really hairy when you have one project, say, that maybe you started 2 years ago and it was built using version, say, 2.0 of this one package. But you also have another project that you started working on last week that uses a much updated version 5.0 of a certain package. There are going to be conflicts if you haven't isolated your two projects in their own environments. Virtual environments in Python help you to do this, right? They essentially package or contain a copy of the Python interpreter, right? The program that runs Python files, along with pip, the program that manages your Python packages for your project. They contain these into a separate folder. This folder would be called your environment folder, typically named env, .env, venv, and for a short while, after you've activated your environment, anytime you type Python and then your Python file name or pip3 and then install whatever package, it will only refer to the Python interpreter and the pip3 program that you've created in this separate virtual environment directory. You'll see what I mean later. If it's still a little bit confusing. But the great thing about it is that after you've installed all your packages for your Python project in your virtual environment, those packages exist only to your project, right? As soon as you deactivate the environment, and I'll show you how to do that later, as soon as you deactivate, no other project on your machine has access to those packages, right? No other machine knows that those packages exist. So this allows you to be extremely flexible and keep your packages clean and maintained so that versions don't conflict with each other, so you're not constantly downgrading or upgrading different versions of packages, and you just have a nice clean mental state whenever you go into developing a Python program. So how do you create a virtual environment? How do you activate one? How do you deactivate one? How does this all actually work? that's what I'll be showing you right now. So I'll type Python 3, and I'm on Mac, so I have to add the 3 at the end. If you're on Windows, you don't. That's going to be the last time I'm going to mention that. So just make sure if you're on Windows, you don't have to put a 3 at the end. If you're on Mac, make sure you put the 3 at the end, because Python 3 is the standard now. Python 2.7 was deprecated, I believe, the beginning of this year. You don't want to be using Python 2 anymore. Python 3 is where it's at. So, given that's out of the way, Python 3. Now I'll type this, right? -m space venv, venv. What does that mean? What does the -m mean? The -m is a special option that you can pass to Python 3. And it essentially instructs Python 3 not to run a Python program that you have in your current directory or any other directory on your machine for that matter. Instead, it's telling Python to look into its own modules, its own functions, pieces of code that came with Python, that came with the installation. And the specific module that I'll be referring to, I'll be calling in this command, is venv. venv obviously stands for virtual environment. Now, I can't just run this right now, because what it expects, what this venv module expects, is a name. And that's going to be the name of my virtual environment folder. So I'll name my virtual environment folder simply the same name as the module, venv, just to keep it simple. Now when I hit enter, it'll wait for a while, doing its thing, and it will return. So it seems like nothing happened, but if I use my lsla command that you learned about last week, we should see right here a new directory was created called venv. So let's explore that for a bit. Let's cd into venv, lsla a bit more. Okay, there's some other folders, .config file. Now the folder that we want to worry about is bin. Bin stands for binary, and it's a typical folder that you'll see a lot, used almost exclusively to store binary files that are programs that you execute. Now, a lot of times, many times, they also contain scripts, right? In the case of Python, there's really no such thing as a binary file, since Python can just execute Python text files, right? Text files that contain Python code. It's just more of a convention that's taken from other programming languages like C++ that does generate binary files. Now, if we look in this directory, in the bin directory, we have a lot of scripts, a lot of binaries, right? We have the Python program there, and you can see that these arrows exist, and they're simply referring to the fact that this isn't a program by itself. This is a program that links to another program. So my Python here links to the Python 3 in the same directory, and my Python 3 here links to, well, my system's Python 3. Then we have pip3, pip 3.8, but then there's activate. And you might have remembered me saying we have to activate our virtual environment before doing anything inside of it. So this is going to come in handy later on when we activate, which is right now. So let's say I just created my virtual environment. What do I do now? Well, we got to activate it. How do we activate it? Simple. We type source and then pass in the path to our activate script. So what source does is it simply takes in the file that you give it, that you pass in, that you write next to it with a space separating. It takes this script file and runs it. That's all it does. Nothing magical going on. Source is simply analogous to, say, run, right? It's saying, hey, run this file. And if I do, then you'll see that in my terminal, and hopefully in your terminals too, this extra little line should pop up next to the prompt, right? Via build Python demo. That's simply referring to the fact that it has detected, my terminal has detected that some virtual environment has been activated, and it is in the directory build Python demo. So yeah, I have my virtual environment activated. Now it's time to go back to the original point, the original purpose of virtual environment, to isolate my packages. Well, what are my packages? You'll notice that there's a file called requirements.txt in this directory. If I cat that out, if I print that out, you can see that for this demo and for your activity, there's only one requirement, there's only one package that we want with a specific version, and that's NumPy. NumPy, now bring over the home page here, is it's a fundamental package for scientific computing with Python. It has a lot of numerical computing tools, it's very performant, a lot of tools with regards to arrays and matrices, and of course open source. Right, so these are all of the things that you can do with Python and NumPy. It's pretty cool, and that's what we'll be using for this week's activity. So, while I could say, go to pip3, install and NumPy, like that, it's not what we want to do. There's a reason why this requirements.txt file is here. It's for us to use. How we use it, simply like so. Pip3 install, but then instead of giving it a package name, we give it the -r option and then the requirements.txt file path. Since it's in our current directory, all I have to write is requirements.txt without any sort of slashes or whatever. And if I hit enter, you can see it reads my requirements.txt file, notices that, oh, I want NumPy along with this specific version that I want, 1.19.2, and downloads it, installs it, and successfully installs it. I do have a warning here that I should upgrade. We'll just ignore that for now. So now if I go pip3 and list, you can see I have NumPy. Pip and setup tools is automatically installed, so that's nothing new there. But NumPy and my version is correct, 1.19.2. So, if all went well, and I'm pretty sure it did, if I run my little main.py file here, I should get no errors. Awesome. Looks like it did everything that it should. And yep, we have our little log file here as well. Great. Okay. So just to show you guys the demo files, I have my main.py over here. And it looks like VS Code has detected a virtual environment. I'll just close that out for now. Yep, so this is what the main.py file contains. Here's a sort of function to help with the greetings. Here's a log file. Okay, cool. So this GitHub repo will of course be given to you guys to explore. However, for your activity, we are going to require you to, and this will also be written down, so be sure to refer to those instructions. I'm just repeating what I heard from Professor Horton. Your activity will simply be to use NumPy, right? To use NumPy, do some sort of matrix operation, along with using the logging library in Python to do some basic logging, right? And also, along with that, using pip and virtual environments in your development process, right? So I'll be kind of going over the closing of virtual environments right now. Let's say you created your virtual environment, you activated it, you installed NumPy, right? Now, when you make a new project, obviously you're not going to have a requirements.txt file, right? You're just going to create a new project in a new directory, create your virtual environment, and it's going to be empty. You're not going to have NumPy in a requirements.txt file there. So, in that case, yes, it is going to be helpful. It's going to be necessary to do pip3 install NumPy. But after you've developed your program and it works and you did the logging and everything, with regards to logging, it's not something you need to install using pip. It's built into Python, so you just got to do import logging there. So that's good. But after everything, how do you get the requirements.txt file? Is it something you manually write and manually have to figure out what the version is? Of course not. As programmers, there are very, very few things we want to be doing manually. Because doing things manually brings mistakes, as we're all human. So, how do we create that requirements.txt file? I will delete the requirements.txt file right now to just show you how you would create it yourself. And that is by using pip3 freeze. Right? So that's this command I said I would get back to. Now I've come back to it. What does freeze do? Well, if we run it, you can see it outputs something very familiar. This was in our requirements.txt file as before. Okay, so would I just copy this and paste it into a new file, name it requirements.txt? You could surely do that, and that would certainly work. But remember what I said about not doing things manually when you don't have to. There's a much easier way to put the output of a command into some kind of text file. And that is by using this operator, this greater than operator in your bash shell. And what this does, can think of it as redirection. It is redirecting the output of this command. And instead of outputting to my terminal, I'm telling it to output to a file named requirements.txt. And if that file doesn't already exist, it will create it and it will save it. So if I run this now, you can see right here in my VS Code pane, I have requirements.txt. So that's how you do it. Remember the greater than operator. You can think of it as half of an arrow pointing that way and saying, hey, run this command, put all the output into this file. Great. So now you have a requirements.txt file, your project works, everything's good, and let's say you even committed things with Git, you added directory, and then you made a little commit. I'm not going to do that right now because I'm in Professor Horton's repository, right? Now what? You're still in the virtual environment, you're still activated, so you got to deactivate it. How do you deactivate it? Oh, very simple. You just run the deactivate command and hit enter. Boom. I don't see the via build Python demo here anymore. That indicates to me that the environment has been deactivated, and if I do install things with pip and such now on, it is going to be installed in my global pip sort of directory, right? And all of my Python programs are going to have access to it, which is something that I don't want for the majority of Python packages. So that's it. That's how to use pip, how to use virtual environments with Python. Hope you guys learned a thing or two. The specific instructions for the activity will be on the website, along with the instructions for Windows and macOS. I explained it a little bit, but they'll just be written up for you for ease of access. Thank you so much, and see you next time.